So I think we'll go directly to our partners at KIMBCN.
Okay. First of all, thank you for inviting us to present the work we're doing in preparing the platform for the Storm project. If you allow me, I will share my screen so that you can have a look at what the platform is conceived to be and what is its purpose. So please just let me know when you can see my screen, which I hope that
yes,
should be.
We can see it. We can see it, Jordi.
Yeah, you
just
can see
put
my
it in
screen.
Full screen, please. Yes.
Yes, absolutely. There you go. You can have it full screen now. So as I was mentioning before, what is a Storm digital platform conceived, and what is the purpose of the digital platform? Well, the digital platform is it was conceived while we were drafting together the project to respond to a key challenge that we identified together with the consortium, which is that even though the solutions for seasonal thermal energy storage solutions are available, are technically mature, they are, however, sometimes difficult to design, compare, and replicate, right? So there are some barriers that need to be addressed regarding this dispersed information. So we have fragmented technical information, a lack of practical design support for even policymakers and technicians trying to work on these solutions. Sometimes there's limited access to real pilot data. You know, we have been seeing today that there are lots of pilot actions being conducted around the Mediterranean basin, but information needs to be shared. And sometimes there's also difficulty in translating the pilots into policy and investment decisions, which is one of the key elements of the NEXT MED program. So the Storm digital platform intends to give an answer to all these gaps, to all this information gaps and let's say issues that need to be addressed in terms of sharing information and having them in a common repository. So who is the platform for? Who is it aimed? Who will share this information? Who will be supported in their decisions by providing the information gathered in the platform? Well, public authorities and municipalities, when they try to design, implement, and invest in pilot on seasonal thermal energy storage systems, energy agencies in charge and planners in charge of these projects, engineers and technical consultants from a technical point of view, researchers and universities, which we do cooperate regularly with more theoretical and practical information, as well as project developers and pilot replicators. So the information that we'll be gathering, as you will see in the platform, will be replicated, and it is expected to be replicated in different sites. So all these users, under our point of view, they need reliable information, theoretical information, but they also need practical tools, practical information, as well as real examples to take information from and to compare and to contrast and to replicate if they can. And also they need a decision support system, right? Not only theory, but digital support, decision support system. So basically the digital platform is conceived as public open access digital hub. You will see that there are different features. All of them are free. Some of them registration will be needed, but it will all be free and available to all the stakeholders. And it's focused on SDE systems in the Mediterranean context. So we're focusing on the Mediterranean basin based on the project that we're implementing at the moment. And the idea is to support, as I was saying before, the design, the assessment, and the replication of solutions. In this sense, what we bring together, as I've mentioned before, is knowledge, tools, data, and a community of practice, all in one integrated environment that will be the Storm digital platform environment, right? It is understood here as an overall environment, including a knowledge hub, interactive design and assessment tools, a Mediterranean STES Atlas, where you can find, compare, and identify information, specific information on the Storm pilot and case studies, and the community and the learning space, which we think it's very important to be provided as well. So each component separately, but all together, support a different step of decision making, a more informed, we think, and a more reliable decision making process when implementing this pilot. So starting with the first set of information that will be provided in the platform is the Knowledge Hub. What we will have here is mostly technical documents, guidelines and reports, best practices, policy relevant material that can help translate complex knowledge. I mean, not all of the stakeholders using the information on the platform will be technical experts on the issue. So what we need to do is to translate this complex knowledge into very valuable and usable information for everyone. And it will also help support early stage understanding and benchmarking of solutions and serve as a reference for planners and decision makers. As you know, the platform, and if you don't know, the platform is being developed at the moment. So I'm going to show you how it would look like, most of the features that will be provided. So the process started at the beginning of this year, but it has already kicked on in the last month. So the platform will be available very soon. So this would be the section including the publications, contributing authors, theoretical information that you can find in the platform. The second part is, besides the theoretical information, what we need to have are tools, valuable tools that support policymakers, technicians, planners, implementers in designing and scaling up this seasonal thermal energy storage systems. And what we will create is a very interactive tool that will support Mediterranean STES design, sizing and performance estimation, technology comparison, cost and impact assessment, and scenario exploration. So how this will be done? This will be done by using different calculators and simulators in the platform. So as you can see here, the first example of a tool is the energy consumption calculator. It will help us estimate the building's heating and cooling energy requirements based on the introduced parameters in the platform. So you can see all the information that will be gathered here that will provide a calculation of the energy requirements. Also, we will include a system performance simulator based on the system type and the information and parameters provided by the users. We will simulate and analyze the STES system performance mainly across a year to 2 months period of time. So you can see all the metrics that will be displayed here. Very important as well when investing in STES systems. So we will provide an STES feasibility assessment wizard. So that will help us evaluate the technical and economic viability of STES solutions for each project. So basically, again, here and based on the parameters included before and parameters based on the inputs provided by the user, we will have a cost estimation, initial investment, and an overall perspective of the operating costs and the energy savings of each action or solution. And also we do provide, among other things, the climate change simulators, as you know, where basically the current conditions might change. So basically we need to adapt to different current climate data expected, basically working on available data for now, but also expected in the projections from here to 2050 for Mediterranean locations that obviously, and as you all know, will be very and severely affected by climate change fluctuations. So that would be the second set of features. This will be followed by Mediterranean STES Atlas. As I was saying before, we're focusing on the Mediterranean area. So what we're providing here is geographic distribution of STES pilots, climate and contextual data, and contextual climate geology zoning layers to support suitability assessment and planning. How will this be done? This will be done by these atlas. Well, we will provide information. As you can see, we are offering here information already on one of the case studies that has already been presented by Joan some minute ago, the Athens University Campus BTS system as well. So what we will be collecting here is information and data on case studies and climate data across the Mediterranean region. at scope. More focused, obviously, we will be working and producing information on the pilot actions developed within the project. So the 4 storm pilot actions that will be implemented or transferred during the process, including technical configurations, lessons learned, and transferable insights for all of us. Again, here the information that will be shown is some of the information that you have already received during the presentation of Joan before. And finally, and we think this is a very important feature of the platform, is the community and learning spaces for stakeholders interested in STES solutions across the Mediterranean. So the features here will be based on open content for visitors, including everything that we have already mentioned before, but also we will, based on registration, and as I mentioned before, free registration, what we will have is some more hands-on information. So learning paths, quizzes on storm certification information, expert moderation forums, validation areas, question and answers, and the expert exchange forum and learning paths. So we think that with integrating all this information, integrating all these features, we might be able to build Mediterranean STS community of practice, which is the main focus of our work package and triggered by the platform. Encourage cross-country learning, which obviously is one of the main benefits of the project, and support capacity building beyond the project lifetime. So here, as you can see, we will have technical discussion areas, system design forums, case study information, policy regulation, so different areas where users and stakeholders can exchange information and discussions. But the whole journey has a sense, and the whole journey is understood as a way of helping policy representatives, municipality, technical representatives, planners, to explore STE's options around the Mediterranean area. What is there? What can we learn from? Consult the Knowledge Hub, receive all the information that has been gathered by the project and have a look at it. Use the tools to assess the feasibility of the solution that they have in mind or that you have in mind. Review with similar pilots what we can take from those pilots, what is transferable from them. Have a check with experts and a forum of discussion, and then move towards implementation. Obviously, the platform is not an answer to that, but it's a way of helping planners in following this whole path from conception, design, and implementation of pilot action. Obviously, this responds to a long-term value and sustainability of the platform, which is designed for long-term availability, to open access and transferability. And obviously, we'll have no dependency on proprietary systems, so we will be open to provide the information to the community of practice that we want to create. And well, with this, I think this is a brief 15 minutes outlook of how the platform will look like and what the purpose of the platform is. And we hope that by using it, by bringing in stakeholders, the Storm platform will contribute to support this community of practice in STES solutions. So thank you for your attention.
Thank you very much, Jordi, for this presentation of where the platform is and its vision. And it's really very exciting to see what it could lead to. It's a lot of work, I know, and we're looking forward to working all together to achieve this. This is very interesting.
Absolutely.
So thank you for your time again. And I think we'll move now to Professor Antonio Rosato, who will give us a feel of where work package 4 is in relation to the Mediterranean zonation related to storm. So Professor Rosato, the floor is yours.
Thank you, Shali. Thank you for your presentation, for the introduction. First of all, I would like to thank the AUB Mediterranean for hosting this special event. It's my pleasure to be here and stay with us. I would like to, as Shadi mentioned, Professor of Building Physics and Building Energy Systems at the University of Campania in Italy. I would like to briefly discuss with you, describe you some of the technical activities that are behind the digital platform presented by Jordi. In particular, I would like to briefly describe you the activities related to the zonation of Mediterranean countries, as well as the ideas related to the design toolkit we are developing for the preliminary design and performance assessment of solar thermal systems integrating seasonal thermal energy storage. My research unit is coordinating the WP4, the work package 4, that is the work package under which these activities are performed. This work package is involving all the countries involved in the STORM project. The work package 4 mainly consists of 3 activities. The activities 411, that is related to the zonation of Mediterranean region. These activities started with a project and will be, has a duration of 12 months, so will be finalized by June 2026. The activity 412, that is related to the joint development of the toolkit, the design toolkit. This activity began in month 7 and will continue until the end of the project. And then the last one, the activity 413, that is related to the joint design of pilots. This activity started in month 3 and will be finalized by June 2026. Let me start with the activity 411 related to zonation. That is the first activity that started with the project. We already discussed about this, but you know that we are discussing about solar systems for heating and cooling, integrating seasonal thermal energy storage. The performance of such kind of systems depends on a number of factors. In particular, among these factors, they depend on, for sure, thermal and cooling energy demands of end users. They depend on the intensity of energy demands, the temporal variation of energy demands, and their interaction with the generation side. Thermal and cooling energy demands of end users mainly depends on characteristics of building envelopes, as well as climatic conditions, mainly outdoor temperature and solar gain loads. In addition, the performance of such kind of systems are greatly affected by the solar energy availability, because we are trying to convert solar energy into thermal, cooling, or electrical energy by using storages. So solar energy availability is one of the key points to be taken into account. Again, as Shadi mentioned this morning, there are several types of seasonal thermal energy storage that can be used. Some of them can be installed above the ground. Some others are installed below the ground. For example, if you use a seasonal thermal energy storage with borehole heat exchangers, in this case, the heat exchanger are installed below the ground. So this means that the properties, the thermophysical properties of the ground are really important in assessing the performance of the storage. So at the end, we can say that the performance of such systems mainly depend on thermal and cooling energy demands, solar energy availability, and ground thermophysical properties. Obviously, so these parameters significantly change with cities, with countries. So the idea in this work package is collecting detailed and accurate data related to the climate, geology, and the ground characteristics of the countries involved in this project, in order to then develop GIS maps, multi-layered GIS maps. The map will consist of a number of layers. Each layer characterizing the characteristics of the countries involved in the storm project in terms of climate, geology, and energy demand. This GIS map will be made public and accessible to stakeholders via the platform, the digital platform developed within the activities of Work Package 3, so that the stakeholders, including researchers, public authorities, and so on, will be allowed to access this tool in order to access such kind of information, characterizing the countries involved in the project, in order to understand the operating conditions under which such kind of systems can be installed and operated. In particular, we developed a GIS map, as I said before, with a number of layers, characterizing the countries in terms of climate, geology, and energy demands. With reference to the climate, the GIS map we developed consists of 3 main layers. The first one related to the annual average solar energy radiation. The second one related to the annual heating degree days, that is a parameter characterizes the outdoor temperature during the heating season. And the third layer is related to the annual cooling degree days. This is a parameter characterizing the outdoor temperature during the cooling season. In terms of ground characteristics, we created 2 additional layers. The first one related to the average thermal conductivity of ground, and the second one related to the average volumetric heat capacity of the ground, because we say that these parameters can affect the performance of the seasonal storage. With reference to the energy and cooling demands, we created 2 layers again. The first one related to the annual average thermal energy demand, and the second one related to the annual average cooling energy demand. All the layers have been integrated into a GIS map that will be integrated into the platform and made, as I said, available public. Activity 413. As we discussed this morning, the performance of such systems depends on a number of factors. Boundary conditions, for sure, change with countries, but the boundary conditions can also change with time, over time. And assessing the performance of such systems is really challenging, because a number of factors affecting the performance is really huge. So this means that in order to accurately assess the performance, design and assess the performance of such systems, we have to take into account the temporal variability of the boundary conditions, as well as the operational components, not only under nominal full load condition, but also the operation under power load conditions, the interaction between components, and building. So assessing design, assessing the performance of such systems require the adoption of accurate dynamic simulation models. With reference to this point, the dynamic simulation software Transys is recognized by the scientific community as one of the most powerful, accurate, and flexible tool able to take into account the variability of boundary operating conditions over time, as well as the interaction of components and the interaction of plant with building. So in the work page 4, we are using mainly this software in order to create, together with all the partners involved in this activity, in order to create dynamic model and simulation of the pilots, first of all, in order to design the pilots and optimize the operation of such kind of systems. So we developed, together with the partners, a dynamic Transys model of each pilot, together in combination with the partners I mentioned, so in coordination with the activities performed within the work package 5, coordinated by Fabio Cardona, University of Palermo. So one of the outputs of the activity will be the availability of dynamic simulation models of the pilots. third activity 412 related to design toolkit. This activity will provide a design toolkit. So in the sense that, as I mentioned, we characterize the countries involved in the project in terms of climate, geology, and energy demands. In addition, we developed a number of transit models, allowing us to simulate dynamically the operation of the systems. The idea is to use this model in order to perform additional analysis and then combine the results of the activity 411, the results of the activity 413 into a toolkit that will be made public, again, accessible to everyone in order to allow for preliminary design and performance assessment of solar systems integrated seasonal thermal energy storage. Again, this tool will be integrated, as Jordi said, into the digital platform under development within the work package number 3. In particular, the idea is to use the dynamic simulation models we already developed for the pilots and use these models as starting point to conduct additional sensitivity analysis, considering different schematics, different climatic conditions, different characteristics of the ground, different technologies, different sizes of components, different control logics in order to attain a huge database. This database will be integrated into the digital platform. Into the digital platform, as Jordi said, the users, the target users of the platform will be allowed to specify a number of inputs, and based on the inputs, based on the database behind the platform, the users will be allowed to obtain a preliminary design of the system as well as an indication about the expected performance, the expected savings with respect to conventional, traditional systems representative of the countries under consideration. Okay. Okay. Thank you for your attention. If you have any questions, please feel free to ask me.
How are we going to integrate Transys to be part of the platform itself?
This is a good question, but we are not interested in integrating Transys with the platform. We would like to develop a database that can be integrated into the platform, so that the platform in the platform you can specify some inputs, then enter into the database and then obtain the outputs. For sure, the database can be updated based on feedbacks on the users and new simulations, so on, so that we are not in the idea is it's not possible to integrate Transys into the platform. So the idea is create a database and integrate this Transys database, the database obtained based on simulations performed with Transys into the platform.
But don't you think the amount of simulation will be scarce unless we create fictitious scenarios and we just dump these as inputs into the platform? Is that what you have in mind?
Yes, the idea is to identify the ranges of boundary conditions under which the simulations can be performed, and then the users can select. And based on these ranges, then we can perform, as I said, a number of simulations covering a wide ranges of operating scenarios, so that we can cover the boundary conditions specified in the platform.
Okay, that's good.
Yes, for sure. In the case, yes, we are always discussing about preliminary design and performance assessment.
We were very clear in the proposal that any design toolkit will be for preliminary design only, like preliminary sizing, so that anybody who is not an expert in this field can start. Yeah. And just to add on what Dr. Antonio mentioned, the idea was to run these simulations on Transys to cover like synthetic data, as if you don't have case histories. Maybe we will find 15 case histories, real ones, even if we look all over the world. This will be an opportunity to create synthetic case histories, run them on Transys, get the results, and then use them with machine learning or anything else to create like a model that would be in the platform.
Yes, this is the idea, using artificial intelligence techniques in order to manage the database we'll create with Transys.
Other questions? Dr. Makasis, if you want to say a few words, please go ahead. Dr. Nicholas is with us online. He is also in the field of geothermal energy and geothermal energy systems. Nice to have you, Nicholas. Thank you for joining.
No, I mean, thanks everyone for the presentations. It's really fascinating to see all the facets that are happening. And yeah, just added a small comment there when we're talking about the database, because if Transys is the limitation that there's licensing involved and so on, perhaps it can be something that grows organically over time as people use it and need a specific case. They can whoever has access to simulation tools can be incorporating that, so then other people can then have access to that data without needing the licensing. Yeah. Overall, very fascinating to see everyone's involvement, and I look forward to hearing more and perhaps getting involved with some of this.
Thank you, Dr. Nicholas. Any other questions before we close this technical summit? All right. So thank you everyone for your attendance.
Thank you.
Thank you, Dr. Sadiq, for hosting us.